Welcome to section 8.3. We're now moving on and we're going to actually deal with simplifying in general. Everything we've done up to this point in time, when I take the square root, I'm left with no square root left. We're also going to talk about adding and subtracting radicals. To understand this, I need to talk about something called the product rule. Now I implied this in that last video, that part 3 of 8.1 and 8.2. What it actually says is that if I have two radicals, the same exact root, product is equal to this. But remember, an equal means I can also do this. If I have a multiplication underneath a square root, I can break up the square root into each of those products. So each of the terms that are being multiplied together. So I can do this as long as notice they're non-negative. That's kind of an important thing. If we're dealing with like square roots, if we're dealing with cube roots, it actually doesn't have to be non-negative. But generally we deal with this because of square roots. So for our sake, the biggest thing here is the fact that if I have multiplication, I can break it up. Now, you might ask why? Well, let's just think about it. If I have these two numbers, what does that mean in terms of exponents? Could you write those as rational exponents? Well, remember, it's a to the 1 over n and b to the 1 over n. Well, if these have the same exponent, based on the power distribution rule, they're actually equal to a times b to the 1 over n, but as a radical, that's the nth root of ab. So this is exactly why we have equalities, actually because of the exponent rules and because of rational exponents. So this is just it's a nice rule, but it doesn't just magically come. It actually is based on all those exponent rules we've already used. Well, let's practice it. And let's just practice doing the multiplication direction first. So how would you multiply these two square roots? Well, remember, if they're both the same root, both have the same root, then I can just multiply what's underneath them, so I get the square root of 15. So I want you to try that with this example. Go ahead. Hopefully, you just multiply what's underneath, and I get 30. Here's a last example. Go ahead and try this one. Notice the difference now is I have cube roots instead of square roots. And again, we can just multiply what's underneath, but we have to maintain the same exact root. So this works for any set of roots as long as these are the same roots. And we're just going to break it down like so. Okay, so let's move on. Let's do some examples. Again, we're going to start with numbers, and then we'll add in variables. So first off, let's talk about the square root of 20. I want to simplify that. Well, what I can do is I can say that's 2 times 10, which is 2 times 2 times 5. And I can break that up, notice, into the square root of 2 times the square root of 5, which the square root of 2 is 2 square root of 5. That's pretty nice. But there's also a different way we could have approached this. So let's start I want to show you two different ways. I'm going to do the first way through all the problems, but the second way is still valid. I can look at this and ask, what is the biggest perfect square that goes into 20? So think of all the perfect square numbers and ask which one goes into 20. Well, as you think about that, hopefully you realize it's 4. 4 goes into it. So again, I can break it up, and what's the square root of 4? Well, it's 2, and I have the square root of 5, that's all that's left. So I get the exact same answer, I just don't have to do this prime factorization. Now this prime factorization is nice because you can actually see explicitly about why this is coming to be. But as this number gets bigger and bigger, that actually might be the most effective because actually you might miss some other square root. So it's a good idea to try both of them at least once, but you can use either or as you go through. Well, what about this one? So square root of 27. So we want to take it. So I'm going to start off and I'm just going to prime factor 27. I want you to take a moment and do that. Well, if you do that, you get 3 times 9, which also 9 breaks into 3 times 3 times 3. We're looking for pairs because it's a square root, so we're looking for 2's. So I have 2 3's. I can break them up and say, okay, I got square root of 3 times 3, and then this other square root's just the ones left over. Because this is going to turn out really nicely into 3, and then we just get the square root of 3 hanging on. So this is the benefit of it, is by doing that prime factorization, you really see really clearly about how things. You're just looking for pairs, and then you're going to identify pairs. So let's try this again, but we do with a cube root. So we need to try prime factorizing this first, and then we'll go from there. Well, you can prime factor into 3 times 2 times 2 times 2. Well, because it's a cube root, I'm looking for 3's. I have 3 2's, so I yank them over, and I leave whatever's left, and that's going to give me 2 cube root of 3. Now be careful, you got to maintain your cube roots the whole time, so you got to use your notation of what root it is. It's a square root, you don't need to do that, but a cube root, please make sure you maintain that. Okay, what about the cube root of 108? So I want you to pause the video and try to do this on your own. Go ahead. Now, first thing I'm going to do is I'm going to pull that -1 over. Now, there is something, because -1 is a negative times a negative times a negative. That's actually going to be -1. Now, for 108, I can prime factorize that into 2 times 2 times 3 times 3 times 3. Now, remember, it's a cube root, so I'm looking for groups of how many? 3. So I don't have 3 2's, but I do have 3 3's. So if I take the 3 3's, the cube root of that is going to give me 3. If I multiply that by -1, it gives me -3, and all I'm left underneath here is a cube root of 2 times 2, or is 4. So this is equal to that. So we did that. This is where prime factorization, so breaking it up into the prime numbers that multiply together, is really, really useful because it helps you see very clearly what the cube roots are and so forth. All right, let's try another one. So when you simplify the square root of 45, now notice we're adding in variables. That's okay. I want you to break it up, and I want you to look at 45 first. So can you do prime factorization of 45? Well, hopefully you look at it and you said, okay, that's 3 times 3 times 5. Now as we do this one, how do I do that? Well, I can actually just leave it as it is, because what I'm going to look for, since this is a square root, there's no number there, but it's actually a 2. I'm looking for the largest multiple of 2 that is less than my number, or equal. Well, since 6 is a multiple of 2, I'm just going to stick with it. What about 7? What's the largest multiple of 2 that's less than 7? In other words, what's the biggest even number that's less than or equal to 7? Well, hopefully you're saying it's 6. So I can break this up as y to the 6th times y. Because remember, there's a 1, so I'd be adding these things together, the exponents. Okay, now let's come back over here to the numbers. I can break that up into the square root of 3 times 3, square root of 5. But this actually comes back to an essential idea. First off, it's a square root. I didn't tell you to assume that they're positive. So we have absolute values. But then we also, it's going to be the x cubed. Because remember, this is the same thing as to the 1/2 power. What's 1/2 of 6? It's 3. Same thing here, we can break that up. And as we go along here, this is going to be 3 square root of 5. This just gets to come down. And here, I'm actually going to get the absolute value of y cubed, because again, it's a square root, absolute values, and 6 divided by 2 is 3. And this part just gets to come along. Now, the best approach at this point in time is you say, okay, what's outside of the square roots? I have a 3, an absolute value of x cubed, and an absolute value of y cubed. So I can put all of those in the front. Now notice this, the product of absolute values is still an absolute value. And then I just say, what's inside my square root? Well, it's 5 times y, because those are those things left over. And that's it. This is kind of a little touchy, so you got to be kind of careful about it to make sure that you stick with it. And I strongly recommend breaking into numbers, breaking into x's, breaking into y's, work your way through, and then recombine in the end. Well, let's try this again, except this time notice add one little detail. I'm assuming that the variables are non-negative. That means I don't need to worry about the absolute values. Okay, so the first thing we're going to do, assuming they're non-negative, I can break them up into these parts. Now, if they're parts, I want you to kind of pause the video and work through it like we did the last one, but don't have to worry about the absolute values. Go ahead and try that. Well, if you did this, notice 48, first off, I'm going to prime factorize that into 2 times 2 times 2 times 2 times 4. Times 3. It's not a 4 in the end. Then for the x cubed, again, I'm going to ask what's the largest even number, so largest multiple of 2, that is smaller than 3. Well, that's 2. I'm left with 1x because 3 minus 2 is 1. What do I get here for 9? Well, that would be 8 and 1. And again, order doesn't really matter. Now we break this up and we get 2 times 2 times and all this. All the 2's, I just can't say that. I'll probably trip over myself. The square root of 3. So I picked pairs. So these are pairs. These are pairs. That's why I have them all over here. I have the x squared and I have the y to the 8th. Well, this, if I break that apart, I get 4. And that's because I take 1, 2 from here and 1, 2 from this pair. Because these first two are just going to give me the square root of 2. I mean, excuse me, I'll get 2 when I take the square root. And the second pair, I'll get 2. And 2 times 2 is 4. Here, the square root of x squared, remember it's half of x of 2 is x. And that square root just gets come down. What's half of 8? It's 4. So I have y to the 4th. Now again, we combine the things that are outside, and we end up with 4x y to the 4th. And then inside, we have 3xy. So this idea about how to simplify is all about breaking them up and looking at them. Well, let's try changing it a little bit. Again, we're going to assume they're non-negative, so that means no absolute values to worry about. But now I have a 4th root. Well, we can approach it the same way. We can break it apart into these. Now, when you think for a second, when it was a square root, I looked for the largest multiples of 2. It's a 4th root, so what am I looking for? Hopefully you're saying largest multiples of 4. So what's the largest multiple of 4? That's 4, 8, 12, 16, etc. It's less than 14. Well, that would be 12. Apparently I didn't have my pause button set right. So it busted all of this out, but this is x to the 12th, and I'm left with 2 left over. Here I have y to the 5th, which I get 4 and a y. And then here, notice, same exact, I'm just breaking it up. What's 12 divided by 4? Well, it's 3. 4 divided by 4 is 1. Combine the outside, combine the inside, and that's what you're left with. All right, I want you all right, so I'm having a problem with my thing here. There we go. All right. So if we go on this next example, I want you to try to pause the video and work through this example. Well, as you did that, first thing hopefully you did is break it up. Now for 27, this is just like all the numbers. We can break that up by the numbers. Now this, what's the largest multiple of 3? Because we're doing it with cubes, it's less than 4. Well, that's 3, and I got 1 left over. What about 7? What's the multiples of 3? Well, that'd be m to the 6th power with 1 left over. And 9, well, that's actually a multiple of 3, so we're just going to leave it as it is. And again, this gives me 3. Here I break it up, and I'm going to take 3 divided by 3, and that's going to give me 1n on the outside, and this 1n is left over. What's 6 divided by 3? Well, it's 2, so I have m squared, cube root of m, and then I have 9 divided by 3, which can be p cubed. What's outside? Just take everything outside and take everything inside, and we're done. All right, one final example, and this is a 7th root. So I want you to pause the video and work through this one. Well, as you did that, first you could have broken in the x and y's. We're looking for multiples of what number? Hopefully you're saying 7. So I'm looking for multiples of 7 that are less than 11. And that would be just, well, 7. And there. So if I do this, I can break this up into 7, and I have 4 left over because 7 plus 4 is 11. Now, for this one, 7 goes into 23. The biggest multiple is 21 because 21 is still less than 23. What's 23 minus 21? Well, that is 2, so it's y squared. This idea, now we can break it up, and here we take 7 divided by 7 is 1. I'm left with over. What's 21 divided by 7? What's y cubed? Again, the y squared, the 7th root of y squared is here. Outside we have x and y cubed, and inside we have 7th root of x to the 4th y squared. So this idea, and notice I didn't have to say that this has to have non-negative values because it's an odd root. So please keep that absolute value in mind as you're working through all these problems, but just break them up slowly by slowly. Good luck. Let me know what questions you have.